my day job in general is I work on the Apache Arrow libraries directly. I primarily work on the native implementations, the C++ and Go implementations, but Voltron itself, a lot of the committers on the Apache Arrow project do work at Voltron Data, and right now the current public product of Voltron is enterprise support for Apache Arrow. And just kind of improving the ecosystem and building those connections and bringing things together. And as he said, I wrote the book on Arrow, literally, because there's just the one, really. Anyways, but yeah, so without further ado, it's hard to talk about Arrow database connectivity if you aren't necessarily familiar with what Arrow is. So that's what we're going to do first. Just a very quick primer on Apache Arrow. You've probably heard it mentioned, people probably talked about it, but you may not actually know what it is, or you might know what it is, and then great, I like that. But in the meantime, so Apache Arrow is a in-memory format, specifically a column-oriented in-memory format that is highly performant for analytics and analytical workflows. The format in memory is identical no matter which implementation you're using. Whether you're using C++, Go, Rust, Java, doesn't matter. The in-memory layout is identical, which means that you can take the bytes, the raw bytes you have, and pass them across the wire. You can pass them in between processes. You can pass them around as is without having to serialize or deserialize. As Tina was just saying about the BigQuery talk about, where they had a huge cost in having to serialize and then deserialize data that they passed from one node to the other with BigQuery. Arrow gets around that. Now, if network latency becomes your problem, yes, the inter-process communication format does allow for compression if that is your bottleneck. But in most cases, your theoretical max limit is just network bandwidth or your memory bandwidth or whatever you can do. And the other big feature of Arrow is that it's polyglot. There's implementations in so many languages. Like, I didn't list them all here. There's more than what's listed there. And that's kind of the big idea there, is that whether you're writing a client or a server, or you're writing anything that can interact with something else, Arrow becomes a glue that you can create interoperability with, while still maintaining that performance and that communication. And that comes from being column-oriented, columnar. If you aren't familiar with the term, if you haven't heard it before, column-oriented kind of goes like this. If you saw Julian's talk about the history of Parquet and Open Lineage earlier today, you saw a similar, it was a similar graphic that he had, where the way you lay out the data in memory. For a row-oriented layout, you typically see it kind of like the one on the right there. It's kind of like that, array of structs. Where the data is in memory is split up based on, you have struct 1, row 2, row 3, so on and so forth. Whereas column-oriented, you're going to group the data for individual columns together in memory. Why does that matter? Well, when you're performing analytical workflows or any kind of interactions and decisions there's a lot of benefits you can get by having that data grouped together. So using the example I just gave you, with the archers and the locations, and I hope you got some of the jokes that were on there. If you wanted to grab all the archers in Europe from that little tiny table, well, in the row-oriented area, you'd have to read, the whole chunk for every row, and then you could jump around in memory, going from row to row, to check which ones you wanted that were actually from Europe, and then get their names from jumping around in memory. And that can cost them. That's not cost effective. You might be able to get away with reading a subset, but CPUs use cache levels, and the cache layers have certain sizes, so you end up just reading the whole chunks of data anyways. In the column-oriented scenario, you're able to just read one chunk of memory that is the value for the location column. And then you get the indexes you need, and then you read one chunk of memory for the names, and now you can just go index to index in the columns, and there you go, you got your data. And now you've reduced your I/O. You didn't have to read anything about the years, so you have less I/O cost. It's one of the reasons why Parquet is so efficient, because you get that column-oriented on disk, so if you only need to read one column, you don't need to read the whole file, you just read chunks for that column. Same idea, but in memory for how you access the memory. The other advantageous piece of it is that vectorization of computation. You may have heard of like SIMD, single instruction, multiple data, where you have the processor runs one instruction and perform an operation on multiple values at one time. Vectorization. One of the requirements to do that is that your data has to be contiguous in memory. You can't take integer here, 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 and here, and run a vector operation on that. You have to copy them all over into a single chunk of memory, then run your vectorized information. But if you have a column-oriented memory buffer, everything's already in that vectorized contiguous chunk. And you can easily run those vectorized operations on them. So that's kind of the pull here. That's why you want the column-oriented data in memory when you're doing things. So, this talk is titled Arrow Database Connectivity. And how do most people interact with databases? Well, they use ODBC and JDBC. So let's start there and kind of go over, okay, in your standard workflow, you're building an application, you want to talk to a database, the standard way it's going to look is kind of something like this. Your application is going to submit a query. That query is going to go to the ODBC, JDBC API. That's going to get sent to whatever driver it's using, which will then send it off using some database-specific network protocol. Database operates, does its query, executes, does its thing. It's going to return that data in the database-specific format. It's going to go back across using that database-specific wire. And then your driver is going to translate that result set into the format that ODBC and JDBC require, which is typically a row-oriented format. And that's kind of your standard workflow nowadays. Now, some people can get around that if you have a good enough driver. The driver can improve that communication, but that's generally how it works. So, JDBC and ODBC exist for a reason. You know, when they were created back in the 80s, it was the idea of making it easier on application developers, so you only had to write against a single API, but you could access tons of other databases and just swap out drivers, which is a good thing. Except that data then and data now and computers have changed a lot. And ODBC and JDBC are row-oriented because at that time, in the 80s, your data sets were primarily tons of rows, fewer columns. That was just the typical way things were operated. And you also weren't dealing with the enormous amount of data that we do now. So when you want that column-oriented interaction, ODBC and JDBC are not good for that, because now you have to transpose that data at both sides. So, but ODBC and JDBC aren't going anywhere. They're ubiquitous. Everyone uses them. They are the generic connector that, you know, if you were making anything, you utilize ODBC, JDBC, or, you know, it's table stakes. If you can't use ODBC and JDBC, then you're dead in the water. So they're not going anywhere. We're not going to kill them. We're not going to get rid of them as much as we want to. So when you have that column-oriented database, Dremio, ClickHouse, Google BigQuery, even DuckDB, when you start wanting to get those improvements and get past that cost of the transposition from columns to rows, you start looking into libraries that do that. You know, TurboDBC, Arrow JDBC, various libraries that try to do that conversion for you, or improve just to reduce those costs. And then when that's not fast enough, you go to the actual database-specific SDKs. But once you go to the database-specific SDK, now you've defeated the purpose of using ODBC and JDBC, because now you're going to have to write an adapter for every single database you want to communicate with so that you can use their individual SDK, and then because you want things to be faster. That's what this is all about. It's performance. And that's where this talk comes in. That's your starting point. That's what you have now. And I'm telling you there's a better way. And that's Arrow database connectivity. Thank you. Okay, I'm done, right? Okay. No, ADBC. So, ADBC is that single client API, but the interface it exposes is Apache Arrow oriented and the Arrow native. We're not going to replace ODBC and JDBC in the generic sense. But if you're doing a bulk column-oriented, columnar computations, analytical workflows, this is what you want to use, and you're going to get benefits, tons of benefits from it. And it's available in lots of languages already, including, if you really like that Go Arrow, the Go Gopher, and the snake icons, see me at my little office hours. I have giant stacks of stickers of them. So please, if you want stickers, come get them. They're adorable and I love them. My graphics team loves me when it's fun when you can go to the graphics team and they're like, I need an image of a gopher with a bow and arrow. Or I need an image of a snake being launched from a bow. So shout out to Voltron Data graphic design guys. You guys nailed it. Okay, so let's look at that example again. That's the workflow we showed earlier. Let's look at that again. But this time we're going to do it using ADBC. So you've got your application, you got your query. You're going to send your query to the API, to the ADBC. ADBC is a spec. And then you're going to hit whatever driver you're using. Whether you're using Arrow Flight SQL, or maybe you're using Postgres because you're going to a row-oriented database. The driver is going to translate the query however it needs to do it, and then send that query in whatever database-specific format it needs. And ideally, the database is going to execute and return Arrow data. That's the ideal scenario. But like if you're going to Postgres, you're not getting Arrow data back. Unfortunately, at least not yet. Maybe they will. Who knows? So when you get the data back, if it is needed, if it's necessary, the driver can then translate, transpose, shift the data into Arrow from whatever that source was. If you have the ideal scenario where you're getting Arrow data back from your database, like if you're using Dremio or BigQuery or anything else that can return Arrow data, then it just passes it through. No translation, no transposing, ideally no copying. It just takes the bytes as they come off the wire and hands the pointer to those bytes to what you need. And then your application just iterates over batches of Apache Arrow data, regardless of where the data came from. So in this case, you can use ADBC and use Arrow interactions and get data from Postgres. And then change your driver out and go to Dremio. At its core, ADBC is just an interface defined in a C header. Anything that can do extern C and expose that interface can be used by the implementations for ADBC. That's the core, it's the basic of it. And the reason for that is because Arrow has a C data interface that's defined. A couple small structures that are a little bit of metadata and then some pointers to the buffers so that you can pass data across a C boundary without copying it. So your driver can take the data it got back as is from the database and just hand it off to the application without the cost of making copies of those buffers of data. And that works no matter what language you're in, because almost every programming language has some way to talk via a C boundary, because that's just the ubiquitousness of the way it is now. The API and the drivers are still under development. We just released version 0.3.0, and that included a SQLite, Postgres, and Arrow Flight SQL drivers. But it did also have implementations in C, C++, Java, Go, Python, Ruby. Someone's building a Rust implementation also. There's an R implementation being worked on, so on and so forth. And if you guys have ideas or want to help contribute, please do. But the idea is that in the header file uses free functions and type defs and enums to maintain as much as possible that ABI compatibility across releases so that things don't break out from under you. So as long as you can meet the interface, you work. So when we're talking about like where does this fit, we're looking at, okay, so now we have the old XKDC, XKCD comic, we had 14 standards, let's make one that fixes it all, now we have 15 standards. Where does ADBC fit? So you've got your row-oriented technologies, JDBC, ODBC. ODBC does have a column-oriented thing, but the type system isn't rich enough to really work with Arrow, and people just don't tend to really use it. And then you have your protocols. You have APIs and protocols. And ADBC is that Arrow native, vendor neutral API. That's where it fits in this whole thing. And like I said before, we're not gonna kill JDBC or ODBC like even as much as we want to. This isn't gonna kill it. But this is gonna give a way forward for doing high performance, bulk, columnar, analytical workflows to get your data, because it ends up being extremely fast. Now, of course, you might say, but wait, I've heard about Arrow Flight and Arrow Flight SQL. Why do I buy, why is there ADBC if I have Arrow Flight or Flight SQL, or why? They complement each other. It's not a replacement. This is not, ADBC does not replace Flight SQL, it's a complement to it. To oversimplify, when you're dealing with a database system, you typically have three components. You've got a client, you've got a server, you've got a transport protocol. Yes, it's oversimplified, but just stay with me here. On the client side, you get a big benefit by having a single API you can code against for your application, that no matter what database you're trying to hit, you don't have to change your code. Just change your connection string. That's very advantageous. Your wire protocol could be different based upon what database you're going. And by having that something like ADBC on the client side, you don't have to care as an application developer. On the server side, if you're a database developer, if you're a database vendor, you get a really cool advantage of if you build, say, an Arrow Flight SQL interface for your database, you get to reach everybody and not have to build your own driver. You just expose a Flight SQL interface and anyone can use your data. Because in addition to ADBC's Flight SQL driver, there's also Dremio released last year a ODBC JDBC driver that works with Arrow Flight SQL. So Arrow Flight SQL becomes a standard for the server side that you just get a ton of stuff for free and can reach all your clients if you're a database developer by having that as your server interface. But if you're not using that, you can still just build an ADBC driver. Maybe you think you have a better way of communication or transport, and you can still make it easy to get that column-oriented interface and not have to pay cost of transposing your data from that column to row. And then often when you're trying to do an analytical workflow, you want the data in column-oriented anyways. So now you went from column to row, and then on the client side, you went back from row to column. And now you're doing all these transpositions, or you can just use ADBC. And that's kind of where we are. Now, yes, some people might not yet be able to switch to ADBC because we don't have all of the drivers yet. They're being worked on when we can, but please, look it up, contribute. It's all open source, just like Arrow. It's part of the Apache Arrow project. So please contribute and come help. I'm going to be working on a Snowflake ADBC driver soon, but there's still needs for like ClickHouse, BigQuery, whatever else. There's still features that aren't fully there for the Postgres one. Now, the fun part, actually showing you code examples of this whole thing in action. Because, well, what good is it if you don't know how to use it? So let's look at the Python package first. You can actually just pip install ADBC driver SQLite, or ADBC driver Postgres, ADBC driver Flight SQL. They're all Python packages that you can install via pip. You can also get them via Conda, or Mamba, whatever you prefer. And the Python API for ADBC implements DBAPI 2.0, so any of your existing code that already relies on Python's DBAPI interface can work directly with ADBC off the bat. But it also adds this fetch arrow table method, that if you have PyArrow available, you can call fetch arrow table, and it'll just hand you the arrow table data without having to convert, without copying, all the benefits I just talked about. And you can see here, like, all you have to do is, if you change, which thing you imported and your connection string, the rest of the code can stay the same, which is the reason why you use ODBC or JDBC in the first place. Only now we're going to get column-oriented. Now, this is the high-level API. There's also a lower-level API. We expose, at the lower level, a driver manager. Remember I said that ADBC at its core is, a C header file that defines an interface. That means that any shared library, any shared object that exposes that extern C interface can be loaded and then delegate to it. So you can dynamically load drivers by just telling it, the path to the shared object. And it loads it up, and then you can use it, as long as it meets the interface, so it has and exposes the functions that it can call. And then that lets you do a couple things. You can use multiple drivers simultaneously. You can create one instance that loads one library, and another instance that loads another library, and there you go. You can decouple your data from specific drivers. Instead of having import ADBC driver SQLite, you can just import ADBC driver manager and then parameterize the driver and the connection string. And now you've further decoupled everything and made it more modular and easier to use, easier to make it more ubiquitous, and it makes the drivers reusable. This one I like a lot because I do a lot of work in Go, and the Arrow Flight SQL driver that is distributed with that Python module is a shared library distributed with the wheel that was written in Go and then compiled to a shared object. And the reason is because you get a single shared object that we can load with almost no dependencies. If I did this traditional C++ way, I'd have to either make a build system to statically link in everything I needed, or I'd have to distribute Flight SQL, libarrow, gRPC, Flight, all of these things. Or I can build it in Go and then distribute one shared object. Not only that, but it means I also I can reuse the code because we needed a native Go implementation anyways. So all I do is take the native Go implementation, wrap it with CGO extern C calls, and now I can use it whether you're coming from C++, because you can just link against it, extern C, or Python, Ruby, R, any of those things that you need to link against that you're not implementing this natively in, can use it, and you have almost no dependencies to it. And it works in multiple environments. I can build it for Windows, I can build it for Mac, I can build it for ARM, I can build it for S390X IBM mainframe. Yes, I have done this. And it's reusable in all those situations. So let's look at the Go side. For the Go interface, it just describes the interface. Notice the difference here is that, the difference being here that in the Python implementation, you had the DBAPI. It used Python's standardized interface and made it available to utilize ADBC while still also giving you the benefits. We do the same thing on the Go side. You've got a native Go driver, but it's also got a driver manager because Go can use CGO, which means I can load any ADBC driver that, say it with me, exposes the C interface. You expose those functions and the Go can use it, and there you go. It's completely reusable. You write it in C++ and I can load it here if I need to. And then we also provide a wrapper. You can wrap around it so that you can use it in the context of Go's standard database interface. And then suddenly you get access to anything that has an ADBC driver with the standard database SQL interface, or you can just use the ADBC interfaces and get the Arrow data directly. It's not difficult to understand it because we use similar concepts. The concepts are fairly equivalent when you're thinking about what we're talking about, the ADBC versus other things. Whether you're dealing with a connection, your query state, prepared statements, result sets, they may be called different things in different APIs and different interfaces, but they're basically equivalent in conceptual idea. So it's not hard to wrap your head around. And we don't stop at just being able to execute the query and get results. You can do bulk ingestion with ADBC. If you have something else that provides you a stream of record batches, you can send those to insert them into a table if the driver supports it. You can send them to create a new table from this list of record batches if the driver implements it. If you have a partitioned result set, so one example with Arrow Flight and Arrow Flight SQL is when you make a request with a query, it can return to you a list of locations. And you consume all the locations, which you can do in parallel to get the whole data set. If your server side can support partitioning out like that. ADBC also supports that as an interface. So if your database does have that way of saying, here's a bunch of partitions that you can get in parallel, ADBC driver can take advantage of that and use it, and you can get the benefits of that parallelization. It also has transaction primitives. We tried to get as much of that primitive based SQL workflow that we could into the interface. But if you look at it and there's a piece you can't do with the interface, file an issue on the repo, please. We want this to be usable and ubiquitous in every scenario we can. So if you want more information, you got the Apache.org/ADBC website has documentation, information, links to the repo, and other things about how you install it, download it, and stuff like that. You can get it there. If you want more information on Apache Arrow in general, maybe you've only heard it and haven't played around that much with it, we have the Apache Arrow docs, or you can get my book. The book is a whole thing on Arrow, but not just explaining the Arrow format and how do you use it, but also in context. Examples of how you make Spark faster using Arrow, of how you can leverage Arrow in different workflows and benefit from it. And the examples in the book are provided in Python, C++, and Go. And there's a GitHub repo that has them all there. Yes, this is definitely my shameless plug. Thank you. But the idea being, get more information as you need. If you need it, find me, talk to me, email me. I'm just matt@voltrondata.com. And yeah, that's what I got.